I've just switched on the recording. Good afternoon, everybody. And once again, my name is David Jacob. I am the Regional Science Coordinator and the Coordinator for Science 21. And today we're going to talk about the new elementary level science assessment and how they are going to be deployed and some of the questions that you have. So if you look at our agenda today, we're going to talk about the written test, which is really a computer-based test, but we're going to be looking specifically at some of those questions from the samples that were given. We're also going to talk about some of our supplemental questions that we have written for our work. We'll also take a look at the investigations, which is where a lot of questions have come from in the last couple of weeks, is how to administrate them, what are the materials. So once again, this is a public forum, so I'm not able to get into specifics about the assessment items, but what I can do is really talk about what are the skills that students need, and I'll be talking about the alignment to the performance expectation. So we're going to first start with this. If you have not seen this, you can see it's on my wall as well. This is the timeline document released by New York State Education Department. It's been revised twice, most recently in April of 2021. And if you look at our first box that's highlighted in yellow here, it says the last administration of the grade 4 test was last year. There is no grade 4 science test this year, and there is a grade 8 test. But what's more important is that in June of 2024, it was the timeline to do the new grade 5 elementary level science assessment, but that has now been moved to April or between April and May. So that timeline has changed, and you should be aware of that. If you're a grade 5 teacher, that means that you need to make some curricular decisions about how do you get through the materials that you need to get through in order to make it in time for that assessment. The other thing that you need to know about that new assessment in June of 2024 is that this year's grade 4 is that cohort of students that will move on to take that, to be the first cohort to take that test in grade 5. But I keep on talking about grade 5. This is not a grade 5 test. This is a grade 3, 4, and 5 assessment. And we'll talk a little bit more about what that is. So if you have ever been into a meeting with me, there is no meeting that we have that is not around the 3 dimensions. The 3 dimensions are the work is really important around the science and engineering practices, which are all the way to the left. Those are the same in grades 3, 4, and 5. That means that all the elements that they articulate in grades 3 are the same that's in grade 4, which is the same in grade 5. The same thing goes for the cross-cutting concepts, which are all the way onto the right, which means that the patterns, cause and effect, scale, proportion, quantity, all of those are the same in grades 3, 4, and 5. What is unique on each grade level is the disciplinary core idea, which means that those things that are in that center column are unique in grades 3, unique in grade 4, and unique in grade 5, and are not repeated. The science and engineering practices and the cross-cutting concepts are repeated over and over again, but the disciplinary core ideas are unique to this. And does this relate to 7 and 8? So no, if you're looking for 7 and 8, this is not related to 7 and 8. So Maria. And also the expectation is finish all units by the test. So everything that is in the grades 3, 4, and 5 standards that are in our curriculum are eligible for assessment. So if you don't get to a unit by the end of the year in grade 5, it means that the students may not have been exposed to a disciplinary core idea. So that's, how you go about that is your district's decision and your decisions as a teacher. So this is the standard page. For those of you who have been in Science 21 professional learning, you know this very well. We've gone over this. We have a lot of administrators that are coming to these sessions as well. And we'll kind of work through what that is. So this is the performance expectation, and what we know is that in New York State Office of Assessment, they use these performance expectations to write assessment questions. And if you see something that's highlighted in yellow in a performance expectation, that means it is only in New York State, and it is part of the New York State Science Learning Standards, not part of the Next Generation Science Standards. So that means that we have deviated in New York slightly for that. And you can see, once again, in the standards, those 3 dimensions are clearly articulated. And if you look at the Science 21 professional curriculum, those are articulated over and over again. We've used the same colors. We've made that as consistent as possible with the state standards. So assessment, update, and review. So what's new about this? Back in 2020, the New York State Education Department released this document, which is called the Performance Level Descriptors. And there is a level 4, level 3, level 2, and level 1 that they have articulated by performance expectation. So you can see the performance expectation is here. And then the articulation of those 4 levels are there. This document I'll provide to you in just a moment when we give you a document of all of these links. But for you, I'm going to give you a moment to take a look at this state level document, and I've articulated this slightly differently, meaning that I've color coded it and I've pulled it out. But I've also put a grade 3, grade 4, and grade 5 up there. So whatever grade level teacher you are, you can kind of you can see what is an expectation of one performance expectation. And I'll stop talking for a moment so you can take time to read. So if you look at this particular document, what is not that different between level 4, level 3, level 2, and level 1 is the balanced and unbalanced forces and the motion of an object. So that is the same. So our DCIs are pretty much consistent all the way through, all the way the same through all 4 of these levels. And the cross-cutting concept is basically the same all the way through as well. So if we're looking at patterns, or we're looking at cause and effect, or total amount of matter is conserved, that means that what's really different is the science and engineering practices. So the science and engineering practices are probably what we've spent the most time working on in our curriculum, kindergarten through grade 5, and given the kids lots of different exposures to those in lots of different ways. So you want to be able to make sure that the students are actually doing the practices the way they're articulated in the standards part of the curriculum. So when you shortcut a lesson, or you kind of say, oh, the kids can't do this, it may be the expectation of what they're doing on the written test or in the investigations. So this is a document that you can kind of use to work through that. And we'll, like I said, we'll put that in the chat in just a moment. The other item that we know about Office of Assessment is they've created an item checklist that is based on an Achieve checklist. They've made some slight revisions to it, but if you look at what's highlighted here in the middle, is that they are using this checklist to ensure that no item goes out to field testing without being assessed in the 3 dimensions. So that means that they're really concerned that the 3 dimensions are articulated in every single cluster of questions that they put out in a final assessment. So let's take a little bit closer look at a few of them. There are 14 items on this checklist, and we're going to take a look at just a couple of them to make sure that you see what this document is communicating to us in the field. So can the specified disciplinary core idea be linked back to a foundational phenomenon? So that means that on the assessment, the students will be looking at a phenomenon and making sense of the disciplinary core idea through other means in that assessment question. The other thing that's really significant here is, can a significant portion of the task be completed successfully using rote knowledge? So you can see that's the only flag that is yes. So if a student can complete the task by memorizing something, that task is thrown out. So that means that for the students that were good at memorizing things, this test is not going to be something that memorizing works on the assessment. They need to do that work, but they need to be able to see who's there. So the next thing that we're looking at is the 3 dimensions of the standards. You can see these are very clearly articulated. Does the task require students to use some understanding of the specific DCI to complete the task? So that means that the students need to know enough about the disciplinary core idea to complete the task, but not memorize it. They also do the students have to use the specific science and engineering practice in order to successfully complete the task? And do students have to use the cross-cutting concept? So you can see those 3 dimensions. So what this communicates to us in the field is that the state assessment writers are looking very specifically at phenomenon-based questions and the 3 dimensions, and that memorization is not something that is recommended for this assessment in particular. So, and we'll see that as we go through some of those a little bit at a time. And if you want to communicate, these are the email boxes for 3 of the critical aspects of state assessment. So one is Office of Curriculum and Instruction, one is Office of State Assessment, and these are generalized email boxes, but someone from Office of Assessment or Curriculum Instruction or Graduation Requirements will answer these questions here. So the elementary level science test, we're going to take a look at some sample questions that are already released. And this is not a grade 5 test. This is it's a cumulative test of grades 3, 4, and 5. And the good news is that the band of SEPs and cross-cutting concepts, once again, are repeated throughout. So Nancy's going to put a document in the chat box right now that is also on our website. So you can go and look at our website and find this at any time, or you can share it with your administrators where that is on the assessment, on the website. But if you take a look at it, what's on this document is the timeline, which I started with, the grade 3 standards, which I started with, the performance level descriptors, which are here as well, standards, PLDs, which the link is right here, the sampler items, which I'm about to go over, a couple are right here, the computer-based testing memo. So these are all state memos. These are not David Jacob written memos. These are state memos. And then also they've recently added frequently asked questions or an FAQ. The link is right here as well. So you can open up all those documents, or if you want to have a conversation with an administrator, you can argue through these from the documents from State Ed. So let's take a look at the generalized formula for an assessment cluster in the elementary level science assessment. So what we know, and I will show you what that looks like specific, but generally the formula is there's some kind of scenario around an idea, and it could be more than one disciplinary core idea, or it could be a single disciplinary core idea. And then the students will be given informational text in that scenario, or data, or charts, or photographs, or any of those things. And then there will be clusters of questions that will either be SEP and DCI in a question, or cross-cutting concept and DCI in a question, or all 3 of those dimensions in one question. So that means that we could have 2-dimensional and 3-dimensional questions in the cluster, but in the cluster, there's all kinds of questions that go through that will be, all 3 dimensions are assessed during those clusters of questions. So literacy matters in this assessment questions. So if we're looking at this for ELS, for the elementary level science assessments, students will be reading complicated or complex science scenarios. They'll also be reading informational text. But the students will also need to be familiar with not just informational text, but models and data tables and charts and graphs and photographs to support, and they extract evidence from those things to support an argument or construct an explanation. So what we're looking for is students to be able to handle extracting evidence from not just literature or informational text, but graphs and charts, images, models, all of those things. So this means that their literacy skills and their scientific literacy skills really do matter on this test. So if you have seen the sampler question, or if you haven't, this was the first page of that sampler. And what you see is a sample informational text and an image with which is a diagram or a model of this beaver. So this is a North American beaver, which is the state animal of New York State. But as soon as I saw this, before I read a word down here, I went, this has something to do with external structures. And how do I know that? Because I'm a Science 21 curriculum writer, and I know that external structures are part of the standards. So I went to it and I went, oh, so this is about external structures of beavers. When I go in to read these things, I'm looking at it through the lens of external structures. And you might want to look at that as helping, one of the ways that the students are looking at it. Looking at images in an informational text may be helpful. So in Science 21, we have provided informational text throughout our curriculum from K through grade 5. And sometimes the critique is that these informational texts are challenging for their students. But once again, we have to grow their growth over time. This will be a test in 5th grade, so they're gearing these readings for 5th grade. But if you want to play Rachmaninoff, you start out with scales and then maybe Happy Birthday and then more complex songs as you go along the way. But in the classroom, the students having practice with informational text in science, not just fictional text, but informational text in science, is something that you can help them with, that they may be better prepared for when they get to when they're in the on the assessment. The other thing, as we've done, this is a grade 5, just happens to be a grade 5, page 9 and 10 in our informational text. But once again, when we're looking at models, we're looking at multiple different models, so the students don't get to see a single model. So sometimes one of the critiques that we get was going, it's doing the same thing over and over again. It's not. It's doing the same thing from 3 different directions. It may be taking a DCI from a science and engineering practice, and that's the focus of the lesson, or it's focusing from a cross-cutting concept lens, or it's trying to influence all 3 of those together and trying to give the students a chance to ask questions or a chance to plan an investigation. So we've very much considered what are the multiple ways, the iterative ways. One student, one lesson, they may not pick it up. They may need to learn about this in multiple different ways. So we've tried to do that as much as possible. So here's an example of looking at modeling from multiple different ways of modeling. So when we take a look at an ELS cluster or an elementary level science cluster, sense making is the focus and not recall. So the students who have been good at memorizing through their whole educational careers may struggle on this assessment. And the students who really are engaged in the science and engineering practices, cross-cutting concepts, and DCIs may really be successful. We may see some different outcomes on this assessment than we have seen before, because memorization is only one skill and not everyone are very highly functioning at that one skill. Students will need practice with that complex informational text. They'll also need practice with complex multiple choice questions, and they'll also have to unpack media, photographs, models, all those kinds of things, as well as I've mentioned. And also students will need to be familiar with new prompts about patterns or cause and effect, or how to construct an explanation. So when we put that language into the Science 21 student pages, teachers saying that's not kid-friendly language. It is standard language. So we're trying to make sure that the students are exposed to it. You can, in the course of the lesson, help students make sense of that, but they want to be able to expose that planning and investigation is an expectation that they'll do on the assessment. So let's take a look at the assessment, the sampler that we have. So here is our informational text and our model of a beaver, and they're going to base their next 6 questions on this. So there's 6 questions about this beaver. So as I saw this, when I turned the page and I saw question number 1 said external structure, that was not me making up external structure. I know it's in the standards, I know it's in the curriculum, and now it's on the assessment. So the students here identify one external structure from the photograph and the reading, and that functions to support the behavior of a beaver in its habitat. Explain how that structure supports the behavior of the beaver. So that means the explanation needs to come with evidence in order for it to be an acceptable answer, because that's what we know from the standards what that looks like. The next level, or the next question that they have, is 4 facts about the beaver, and it says the teeth of the beaver are an important structure that serves many functions for the survival of the beaver. The student recorded some other facts about beaver teeth. So they now have to look at a multiple choice question in which there are 4 facts that they need to read, reason with, and then say which are the 2 facts. In the old elementary level test, we might have seen 2 facts about beaver teeth and 2 facts about beaver feet. These are 4 facts. The beaver has teeth, 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 teeth. So we have 4 teeth questions. They have to choose which one of these 2 are the best that serves, that allows for the support of the survival of the beaver. The next page of the assessment cluster is a map. So this is a shout out to my social studies colleagues, that this is geographic reasoning as well as getting information from media. So the map below shows some graded, shaded areas about where beavers live. Then there are given 2 graphs with beaver data on it. And then the question says, using evidence from the map and the graphs, which claim accurately describes in a particular habit beavers sometimes survive well, less well, or cannot survive at all. If there's any grade 3 teachers in the room, you know that well, less well, and not at all are on our curriculum. That was not by accident. That is the language in the standards, that was the language in our curriculum, and that is the language in an assessment question. So it wasn't arbitrary. There's very few arbitrary pieces of language that we used in Science 21. We tried to go back to those standards as much as possible. So now the students will need to be able to look at these claims and be able to choose which one is the most accurate. Question number 4 is about the graphing. Now I want to move into questions 5 and 6. So in 5 and 6, we now have an engineering question where the student has to look at the criteria of the project listed below, look at 2 solutions, and they then will need to answer questions, 2 questions about this from an engineering perspective. So which statement best explains why one of the designs is more appropriate? So one of the things that we do in grade 3, if you remember in our how they do a magnet from, and I'm calling on grade 3 because there's a lot of grade 3 on this grade 5 assessment. So we had the students be able to design a solution using magnets. But they didn't actually build it. You can see they're not building a beaver pond here, but they did have them look at multiple solutions and give them positive feedback and warm and cool feedback on other students' solutions. So that was not by accident, it was by design, because in the standards, students will have to look at multiple solutions and figure out which one is the best one. So that's what the cluster of questions looks like, and there are a couple more clusters for you to look at in that sampler, so you can take a look at this. This is the memo about the computer-based testing. You can see that in spring of 2024, it is required for ELA, math, and science. So that means that this written test will be a computer-based test, and you need to prepare your students for that. So one of the ways that Science 21 has helped, we actually partnered this year with STEMSIMS, and what we have done is on our website, you can find a document in our assessment piece about accessing these STEM sims. So these are computer simulations that has an offline paper component to be able to work through them, but it's a way of starting to get your students comfortable with working on science questions or science things that are related to computer work. So these simulations are great. And for administrators in the room, these are free, they're offline, but if you purchase the product through STEMSIMS, I don't get a cut. They're giving us stuff for free, but I'm telling you about this, that you also have access for this in high school and middle school to be able to use these simulations in other ways. So it's a great product. That's why we partnered with them. They reached out to us and we said, please let us work with you. We wrote the lesson, but it's their simulation. So it's really very, very nice combination with this. So now we're going to move into a memo about the investigation. So I've talked about the written test and how it's a computer test. Now we're going to talk about the investigations. So this is the memo that was released by State Ed about the investigations. And there's a few things that I want to draw your attention to. One is this first sentence. Teachers must be certain that all students successfully complete the required investigations before the administration of the elementary or intermediate level science tests. Rarely do I see in a state memo must and all. That is not always a combination there. So looking at must and all means that must and all is everyone. So the students need to take these investigations. There are some exceptions that the state will honor, but you have to work with those for in special circumstances. But that's not going to be a blanket thing for students. If students are in your district, they need to be able to sit for those. Also below on this memo talks about the performance expectations. You can see the end of them and the name of the investigation. This is what's in the bag, cloud in a bottle, light it up, and circle of life. So that means that these are the performance expectations that we're working with. And at least 15% of the questions on the written test will measure the content related to the performance expectations measured by the investigations. So that means that these 4 are ones that are going to make up 15% of the test. All the other ones could be anything from grades 3, 4, and 5. So just be aware that it is a 3, 4, and 5, and what does that look like? Also, that districts must keep the student answer packets for the investigations 6 months past the written test. So if you do an investigation in grade 3, they have to be maintained by the district over the summer or anywhere in grade 3, over grade 4, and into grade 5 and 6 months beyond the test. So that's something for your administration to be able to know how they're going to logistically manage that. It can be done electronically for administrators, so that's something that you can do, but it's something that is something that you need to manage in some way.
David, you have just a couple of questions that just
Sure.
popped up.
Great. Let me just take a quick look
Yep.
at that. Because what Oh, you know what? Let me look at. Let me get through all of it. There's a time, and I have another one up there, Nancy. So let me look at that at another time. And I think there is, or we can answer that at another point. And guidance administrator online. So there is something about the online version of this. Look at the FAQs. Once again, I don't want to answer questions that are State Office of Assessment questions, but it may be something in the FAQ about that. I heard Bo's working to modify for special ed that. So we did have some work on that. Once again, these are not associated with the investigation, so I want to keep my focus. So you can email me those questions later, and I'll answer them offline. The next thing that's in here that's important for you to know is that the principals portal is where you can get it. I cannot post these investigations on our Science 21 website. I can't put them in the kits. They are secure items. So that's why I'm being very careful about what I'm saying in a public forum about the investigations. I'm keeping them tight to what is released on documents that are accessible to the public. But you can look at these investigations right now, and you should look at them pretty quickly in a little bit. I'm thinking that's Debbie Rose. If you put your question in the chat box, Debbie, I'll try to work with that. Once again, I have another session after this, so I want to make sure that I get to everything that I need to. And am I running behind, Nancy? What's our next session? Okay, 2. Okay. So in this next slide, we have a how to prepare investigations. This is not from a state document. This is not from a national document. This is David's thinking out loud and how to figure things out. So this is my sense making on a slide. If you look at the 4 things that I put in blue, those are how you might deal with investigation. So planning an investigation is asking questions. It may be defining problems. It may be designing solutions or developing models. When you're planning an investigation, sometimes developing models helps in that planning. When you're carrying out a model, you could be designing a solution or using mathematical and computational thinking. All of those are part of this as well. Analyzing your investigation. So after you've planned it, after you've carried it out, you may want to look at analyzing what that data is. So analyzing and interpreting data is something that we want to get students to be able to do. And developing, using, and revising models are part of that analysis stage as well. So constructing explanations is part of the communicating it out. So if you look that I have engaging an argument in both the analysis, because you may start to construct engage in an argument and then recognize that you don't have enough evidence to support your claim, so you may need to go back. And I also want to take this moment just to reiterate something that we've said a bunch of times in our professional learning, is there's a difference between an investigation and an experiment. An investigation means, oh, let me walk outside. Is it raining? That's an investigation. Looking and reading is an investigation. An experiment is a very specific investigation where there is a control and a variable. So in these investigations, they are called investigations. Not all of them are experiments. Not all of them have a control and variable. Some of them are using models to be able to make some understanding of things. And then if we look at our lenses for student analysis, we also have patterns could be used in analyzing data. Cause and effect could be used in analyzing what is happening and part of our communicating results. So when you're thinking about preparing students for these investigations, you may want to think about how we work through all of those pieces. So what is the investigation, and what are the things that you need to look at as a teacher with your principals? So there are 4 basic things that are in those investigation packets. One is the teacher materials. One is the student directions. Another one is the answer packets, and then there is a rubric that is for scoring the actual investigation. So if we look at the teacher materials, the overview is the standards alignment. So they actually talk about the performance expectation and the three dimensions that you will find in that investigation. That is a shout out to you as teachers to say, are my students prepared to do this investigation given this performance expectation, given these three dimensions? Are my students able and capable to do this? Because that's where there is. Just like Science 21 curriculum is aligned to those standards, so are these investigations. So you should review the teacher directions, the materials that are expected. Do you have all the materials in order for that investigation to work? What is the preparation? You should read through the student directions and see how they're slightly different from the teacher. What are the teacher directions and what's missing in the student directions that you may need to say out loud or you may need to facilitate in some way? There's an answer key and exemplars for you to look at. And then in student directions, there are actually check boxes, but it's check lines that there are steps that they have to follow. So these are just the steps. Sometimes they collect data in that, or sometimes there's information in that. And then there are one or two student packets. One is where they collect their data, and another one is where they actually answer questions. So when we look at answering questions for that, that packet, and did I go over? I feel like I didn't say that today. Oh, the homework piece. Did I mention this part about the homework? Is that sometimes, and maybe I glossed over this, I don't think I said this out loud, is that this part of this is that the actual time needed for the required laboratory activities may vary depending on the length of the scheduled laboratory periods, whether lab questions are to be completed in class or outside for homework. So I think I breezed over that pretty quickly. Yes, so that means that some of the answer packet could be used as homework. So that's another whole kettle of fish that you want to talk with your administrators about. Do you want those packets to go home? Remember, you need to hold on to those packets, and that is the kids' evidence that they actually did the investigation. So it's one of those things that you need to carefully consider as a district. So now let's, in this memo that is in that has been repeatedly in there, these are the four that are there. One is a paper task. The grade 3 task is a paper task, really very simple to set up for. You need very little materials. The lighted up task is a little bit more complicated there, and what's in the bag is little messy, and it deals with Ziploc bags and Alka-Seltzer. And then Cloud in a Bottle is a very specific apparatus that the students need to manipulate that. It is aligned to a grade 3 performance expectation, but for a number of reasons, we think it should be done in grade 5. You can do that wherever you want, but listen to my to the next couple of slides, because we'll actually articulate what that means. And there's a bunch of questions about students moving in and out, and I see Debbie's question as well. Let me get through the rest of this, and I'll answer those at the very end as we talk about how to do that. So they're very good questions, and I want to be able to get to those as well. So I'm going to talk about the first one. So the first investigation is a grade 3 aligned investigation, and it is aligned to inheritance and variation of traits, life cycles and traits. It is what each student will need is student directions with their checkboxes and one student answer packet. There are 5 steps to the instructions. Students will create 3 life cycle models. They will produce them on that test, and they need to be able to do that. There's 8 steps, 8 multi-step questions, so there's a bunch of questions around this, but they have to do this. Fairly simple, and I would expect after the students do the Science 21 lessons that are associated with this, they're going, this is easy. Wouldn't it be nice for a student to get to an assessment question that they said, this is easy? So what we're looking at is in grade 3, unit 4 alignment, it is lesson 8. So what we do in lesson 8 is that there are multiple things to cut out, and the students will then have to use a scaffolded life cycle that we created in a student page. And if you look at this life cycle, there's arrows that go this way. So birth, growth, reproduction, and birth again. There is a section that goes to death, and we'll talk specifically why that is important because it's in the standards. We didn't make that up. But we can see that this is very scaffolded. Then we have the students look at multiple other species. Remember, we're trying to get redundancy in here. So we have black bears, we have golden eagles, we have salmon, and we have the next lesson, which is lesson 9. We have an unscaffolded butterfly. Remember, in grade 3, we're watching the development of butterflies live in real time. They actually get larvae to look at, and it's really fun and engaging for kids. Here's the pictures that go with that. We also have a scaffolded version of this. So it's called Images A, and it goes with our student pages that are also scaffolded. One which is nothing, and the students just have to make up their own life cycle, and one that is scaffolded with the elements and the stages that they need to put in there. Then in our assessment, we actually have another life cycle. So once again, you could do it after lesson 8, you could do it after lesson 9, you could do it after lesson 10, but there is a whole bunch of ways that the kids, that's why I'm saying, by the time they do the state assessment when they're gone, this is so easy. Why are we doing this again? But it is one of those things that you want to look at. If you think your kids are really rocking it after lesson 8, then maybe that's when you do the assessment. If you do 8 and 9 and go, that's maybe where it is, or maybe you cut this from the final assessment if they're doing it in the state assessment. So what the assessment demands are for the students is that students will need to identify evidence about life cycle of plants and animals from reading passages to support claims. So there's an informational text that the students have to decode there. There will also be students will need to use models and that they create and models that they are given. So they are creating some models and they are being given models, and they have to be able to construct an explanation and support a claim. Students will then make simple prediction about events and support that with evidence. So in their circle of life task, they need to make some very, very simple predictions, but it's really age appropriate. Students will then identify the life cycle stage that is not shown in their constructed models. So when I'm looking at this, look at the very specific performance expectation that this investigation is aligned to. It says develop models to describe that organisms have unique and diverse life cycles, but all have common birth, growth, reproduction, and death. It's in the standards, it is on these investigations, and it is in the assessment. So just make sure that you're aware of that as a third grade teacher, and you handle that appropriately as well. So let's move on to the next investigation. So this is a grade 4 investigation. There are student directions. There is a student answer packet 1, which is group data collection, and answer packet 2, which is their individual questions where they're individually assessed. There are 10 steps in this investigation with checkboxes. There's a data table and there are some models in this packet 1. And then there are 7 multi-step questions for the students. These are the materials. Not all the materials you can find in the Science 21 curriculum box. So there will be more materials that your district will need to purchase. And we'll talk a little bit about materials at the end of this. So this investigation was a little bit of a curveball for us at Science 21. We didn't expect it to be constructed the way it was, and what we're now doing is we feel like there's a little bit of a gap in knowledge from those students to be able to look at this and say, do they have enough to really complete this task? So what we're doing is we're actually creating a 7A lesson that we're currently piloting right now. But what it's designed to do is to fill in some gaps. And there's a video that goes with this. So there's some technical knowledge that the students will need in order to do this successfully. We've done it in a video, so you don't have to manage all of that yourself. But what the students are doing in this supplemental lesson is they're going to build a very simple circuit, and then they're going to develop a circuit diagram, which is a model of that circuit. Then they're going to learn something through a video, and then they're going to develop a more complicated circuit diagram, their model, and then they're going to be given an opportunity to build it and test it. So it does fit into the model. We actually think this is going to enhance what we're doing in Science 21, but it is a slightly different thing than what we expected. So we'll put this on our website as soon as we possibly can. I think we have 2 classrooms that are piloting that lesson right now. So It's also off for the PE alignment for a little bit. So somebody actually questioned me already going, but this is an energy performance expectation, and you're suggesting that we do it in waves. Let me tell you why. So in Unit 2, these are the 4 performance expectations that are expected in Grade 4, Unit 2. In Grade for Unit 3, we only have 2 performance expectations. So in order to even out the units a little bit and to make it easier on teachers that we tried to combine some things. There's a lot of energy and waves there's a lot of crossover here. So what we decided to do is actually move this performance expectation. We do it slightly in Unit 2, but we do it more robustly in Unit 3. And you can see that we've kind of merge those two together. If you're a 4th grade teacher, you know we've merged the informational text in that unit as well, in those 2 units as well. So what students are expected to do on the assessment is they will carry out an investigation and collect observations. Then the students will have to identify parts of a given model. So once again, given a model, what are the parts of those and how do they work together? Students will plan an investigation. So later on in this task, the students will plan an investigation to design a circuit, which is engineering, and which has an expected outcome, which is making, I can't talk about it. So you'll look at it in the assessment. So students will develop a model of their investigated circuit, but they do not have to identify types. So if you remember, if you're a 4th grade teacher, you really made sure that they knew the difference between a series and a parallel. They need to know what the difference is and how they could be different, but they are never asked the words of identifying series or parallel. So we throw that in there, but just be aware that that's not the most important part of those lessons. They will also be expected to identify criteria and constraints of an engineering design. So in lesson 6, what we do is we have the students use our engineering cycle, which we've used since kindergarten with some modifications. But here is the constraints and criteria. We ask them right up front. So we're trying to make sure that the students get that practice with constraints and criteria. Then they are going to design either a light transmitting device or a sound transmitting device. In lesson 7, they start to build it. Then 7A comes in where they're given new information about how they may build this slightly differently. And then they refine it in lesson 8. And in lesson 8, what they're doing is they're saying what kind of changes did they make, and what are the advantages and disadvantages of their design. So this was also another one that's a little bit off from what exactly the state did, but I think it fits in really nice into what we're doing in Unit 3 and how we kind of combine things to make it easier for you as teachers. So now I'm going to switch into the grade 5 structure and properties of matter. So if you're a grade 5 teacher, you know this, you've been through this unit already. There are 13 steps to this investigation. So there's a lot of steps to do. And there are 2 packets. There's a packet 1 where they collect data, small group data, and whole class data. And they'll have to talk about that whole class data. Then there are 9 questions. So this is a very question-rich task. Here are the materials that are in there. It's Alka-Seltzer and Ziplocs, water, and they're going to actually do it in the investigation. So we've aligned it to lesson 4 and lesson 6. We suggest you can do it after lesson 4 or after lesson 6, depending on what you're doing. But the assessment demands is the students will carry out an investigation and collect observations in a table. Then they will put all of that into a class data table, and they have to analyze the reliability of that class data. So that is good. We've got that going all throughout Science 21, but understand that this is where talking about your class data really matters in instruction, so they can do that on the assessment questions. Students will argue from evidence, making a claim from evidence, blah, blah, blah. We know how to do that. Students will need to discuss conservation of mass. So if you remember in grade 5, unit 2, we talk about conservation of mass in multiple lessons, and we try to make sure that they get through that really pretty soundly. Students will also construct an explanation using cause and effect. So there is that 2-dimensional that you really are very explicit there. And they will have to identify the variables and constraints of an investigation. So there's a lot going on in here, but it's something that is doable. In lesson 4, we did the involving dissolving in grade 5. And that means that they're going to use this data table and then figure out what happened. They have to say what this is about mass and how they're talking about the conservation of mass. Then lesson 6, what they're doing is a new substance formed? I'm pointing that out because that's important when we start talking about the performance expectation. So in that lesson, what they are doing is they're mixing either baking soda and water, baking soda and cream of tartar, baking soda, baking powder, vinegar and water, and they're doing all of these mixes. Really pretty simple, but one of the questions that they are asked is, was a new substance formed? So when they are producing a gas, there is a new substance formed. Why is that important? Because in the performance expectation, which is outlined here, conduct an investigation to determine whether mixing of two or more substances results in a new substance. So this is where that alignment goes. And Science 21, we've kind of aligned that pretty well in grade 5 as well. So in the last investigation, this is the one that is aligned to grade 3, but we recommend that it goes to grade 5. And there's a few reasons just on the slide. So there are 2 answer packets in here. One is a group collection data, and one is an investigation planning and prediction. So they have to do a bunch in that one. There is also 21 steps of this instructions. So for grade 3, although they should be able to do it, you may want to say there may be an alignment a little bit better in grade 5. There is also 9 questions with this, and there is extra data that they have to analyze. So you want to make sure that you're doing this consciously, and what do you think is right. So in grade 3, this is the performance expectation. You can see that this is highlighted in yellow here, which means it's a New York State only performance expectation. But what they're doing here is they're making connections between weather and water processes on the Earth systems. In grade 5, unit 2, we have them developing a model using matter that of particles too small to be seen. We have a specific lesson in grade 5 where they're looking at pressure in a syringe. So it may be aligned there as well. And then in grade 5, unit 3, we have them developing a model to describe the best way of the interactions between the geosphere, biosphere, hydrosphere, and atmosphere. So let's take a look at what they are. In grade 3, unit 3, lesson 3, condensation is what they're talking about. In grade 5, unit 2, lesson 8, it's pressure with the syringe. In grade 5, unit 3, lesson 3, it's water cycle. So what is the assessment demanding? Once again, think of this, is this a third grade thing that you want to do? They will plan and carry out an investigation and collect observations in 2 tables. Then they will compare results in an established table, and they will apply cause and effect to an explanation. They will also provide evidence of a phenomenon in an explanation. They will also provide, they will be given informational text, so they have to read more in grade 3 with this and provide evidence for an explanation. And they'll also have to do predictions. So it can be done in grade 3. It certainly can be done in grade 3, but you may want to think about the complexity. This is the grade 3 task, and what they're doing is they're actually building a model, a 3D model of condensation and cloud formation, and they're doing it here. Then they revise their model after they look at it. And in grade 5, this is the one where they're doing the syringe task. And in grade 5, unit 3, they're actually making a model. Once again, they're doing a 3-dimensional model of cloud formation and the forces that go into cloud formation, and it may be better there as well. This is more data that they're working with. So one of the things that you may want to concern yourself with, so I see there's a bunch of questions about changing where you're going. We may need to change our pacing guide to match that April-May work, and we'll work on doing that next year. The other thing is maybe kits delivery schedule may need to be changed. So tomorrow we're actually sending out a poll to administrators whether your school can accept our Science 21 kits in August and December, because if we shift our kitting, we need to make sure that we can deliver them in the time frame. We're working with 85 districts around the state, and it's challenging for us to get our kits out on time. Kits can't be differentiated grade 5 separate from grade 4 with how our warehouse works. So this is something that a couple of people have taken pictures of, so you may want to take pictures of this, so I'll put it all at once, is considerations for your school district. So what are you going to do to ensure that students are eligible, or how do you track that data to make sure that they're eligible? Where are you going to put that? Where are you going to house it? How are you going to manage all that data? Those are important things for your district to consider. When are you going to administer each task? Are you going to do it grade by grade? Or are you going to do it all in grade 5? If you do it all in grade 5, knowing that you have to do all of those tasks, plus you have an assessment somewhere between April and May. How are you going to fit all of that into grade 5? What are the discussions that you need to do to make that happen? How will teachers prepare for each task? Where are the materials going to come from? How much materials do you need? All of those things. How many sets do you think about consumed versus non-consumed? In the electrical one, there's nothing consumed, except sometimes the bulbs burned out. In the Alka-Seltzer one, there's a lot of consumed in that, so you may want to think about all of those as well. So materials, Science 21 will not be supplying materials for these assessments. We're curriculum work, and you can see that everyone may need this a little bit different. Another location that can do that better than we can is what we're doing. So we're actually providing tomorrow a memo to your administrators with the poll of where you can actually get these supplies for these investigations. So we have been working with wards for a while. They're in Rochester, New York. We've actually been working with them on these investigations. They've been asking us questions. We've been asking them questions. They've actually put together some kits to put together. We have some kits that they can do, which is awesome. And there's also other sources, so I don't want to be a single source and say this is where you got to do it. You can also buy it from other BOCES and for Fisher Scientific. Other BOCES are not quite ready yet for statewide employment of this, but it may be something that you want to work with. Scheduling of when the classes do it can maybe help reduce some of the materials that you need, especially in that electrical one. And also the paper one is easy. You don't need materials for that. That how we'll help teachers is we're going to create videos that will be on our website behind our paywall. Since they're behind our paywall, we can be a little bit more explicit with how that task is run. So what we'll do is we'll say, these are the 4 investigations. We'll put them on the grade 3, 4, and 5 websites. But for you as a teacher, if you're doing it in September or in October or November, you may need that information just when you need it. And coming to training at BOCES may be really challenging. So we're hoping to make that video be the place what we're working on. So why do these assessments matter is that they are authentic assessments. And if you look at Grant Wiggins, who's probably one of the authentic assessment gurus, is he's looking at authentic assessment in lots of ways. It's also progressive in K through 12. And how do you work with this in the lower grades really matters at our upper grades as well. And also the assessments are consistent with what's happening around the United States. There are 20 states that have adopted next generation science standards and 24 that have adopted something like it, just like New York. So they are consistent with what's going on around the country. And it's really designed to measure the learning shifts, not just memorizing, but are they able to do those things as well? So my biggest concern is how do you as elementary teachers find time for this? Students need time to practice with these 3 dimensions. The literacy matters, is being able to go back and forth and making sure that they're doing literacy during their science time and maybe doing science during their literacy time might help for some of those helps. And then problem solving across the board helps in all the disciplines. So it may be those things that you want to work with. So I'm now going to delve with questions. Minnie said, do you suggest that we do cloud in a bottle in grade 5? And yeah, I do make that. That's the recommendation that we're making just from a maturity level, the complexity of the task that it is, and all the things that go with that. So Debbie, I see you have David, but I don't see are we scoring these in-house? So yes, we are scoring these in-house. So you don't need to send them out in any way. And you'll do have a scoring rubric for that as well. Let me go back to the other ones. For the investigation, students can complete the investigations within the grade level. So the grade 3 investigation can be completed in grade 3. Yes, that would be probably the easiest way on the grade 5 teacher, because especially when we know that there's what we've identified is one that belongs in grade 3, one that belongs in grade 4, and the other grade 3 probably should wait till grade 5. It doesn't belong there, but it probably would be best just for the complexity of the task. And there's one that is explicitly grade 5. So that is what we're looking at it. Tina Fernandez wrote to me privately. She says, if a student moves to the district in grade 5, will they need to make up investigations done in grade 3 and grade 4? That's going to be the biggest complication of this process. They may need to, or if you can get it from their sending district, if they're from New York, or it may be an Office of Assessment that grants some kind of waiver for that. So that might be something that, once again, how do you talk through all of those pieces is going to be kind of important. Have you been able to find guidance on administering the investigation online? I think I explained that earlier. They move from another New York district. This is, when do you think this will be available? So, Robert, those are on the principal portal right now. If you look in the memo that I sent, there's actually instructions from state how to access those. So you can find those right now, and you can start looking at and discussing and looking at what the materials you need. Bottle. Pilot. Sorry, I meant when is the 7A pilot lesson will be? It'll be out there very shortly. We're trying to get that as quickly as possible. If not, we'll probably, if we don't get it in the next couple of weeks, we'll probably put that one up unpiloted, saying that it's unpiloted, and we may update that as it goes. So we're trying to be as exclusive as we can. We got another session, so I'm sorry. If you have any other questions, email Nancy, me, or Harry, and we'll get them. If it's a bunch of questions from a district, I'm going to have to end this meeting so I can get into my next one, which has just been gangbusters all day. So thank you. I think that's 5 for me so far, and we're going to kind of go. Once again, ask questions as you go along, or if you're in sessions right now, you can always ask some of your professional learning facilitators. A lot of them are in these sessions today, and they may be able to help as well. So thanks very much, everyone, and have a good day.